My name is Tom Albright. I'm currently the president of the Academy of Neuroscience for Architecture, and I want to invite you to the latest in our series of lectures. These lectures are called Interfaces. The title of this one is Circadian Regulation in a Light-Dark Cycle, and they're called interfaces because what we try to do is pair a neuroscientist with an architect on the program, the idea being that we're exploring the boundary between these two fields, which is an emerging area of study. It's the reason for existence of the Academy of Neuroscience for Architecture, and we're very happy that you've all come out to hear this evening. I want to welcome you to my professional home because I'm also a member of the faculty here at the Salk Institute. Now, ANFA, the Academy of Neuroscience for Architecture, has been in existence for 10 years now. It started here in San Diego, and it was founded by many of the people in this room. One in particular is John Eberhard, who is the founding director. He's sitting in the second row right here. John today has come all the way from Washington, D.C. to be with us, and we're very pleased that he's here because he placed the seed for this organization. He put this into existence, and we're now doing this because of his initial work. And he did this as he and a group of his colleagues 10 years ago were awarded the La Trobe Fellowship from the College of Fellows of the American Institute of Architects to basically found this organization. They did so. It was part of the AIA meeting was held in San Diego in 2003, and the legacy project for that group of architects was basically the creation of ANFA as part of this La Trobe Fellowship. And John actually spent 2 years here in San Diego working with Alison Whitelaw and Gil Cook and Eduardo. You were there at the outset also. He was in, oh, that's right, he was, yes. John was actually teaching both at UCSD and at the New School downtown during that period of time in which he was here. And so San Diego is unique in that there are visionary architects here, but there are also, when it comes to neuroscience, this is the center of the universe. And so there were lots of neuroscientists to draw from, and Rusty Gage, who's here on the faculty at the Salk Institute, was one of the founding members, and he actually delivered the address at the American Institute. He was a keynote speaker at the American Institute of Architects meeting in 2003 here in San Diego. And that was really sort of the kickoff of this organization, which once again has been in existence for 10 years. Now we do a lot of things, and much of what we do is outreach to the community to try and help people understand why this is important. As long as people have been building buildings, there has been an effort to have those buildings accommodate our cognitive needs, our psychological needs, our mental health needs. And the new thing that we have now is the modern field of neuroscience. Neuroscience, in its modern form, has been in existence for roughly 50 years. And we've learned an enormous amount about how the brain develops, how it's organized, and how it functions. And the hope is, and this is part of the mission of ANFA, the hope is that we can take that information and identify ways of building better buildings, augmenting existing buildings, such that they facilitate our existence in those buildings. And by that I mean that they, for example, that they help improve learning in a classroom, that they help improve healthcare recovery in a hospital, or they help make people more at ease in their homes or in public places like airports. So these are the goals, and neuroscience has a lot to contribute. And what we've been doing over the past 10 years is trying to find that connection. We speak different languages, neuroscience and scientists and architects. We have different backgrounds, different methods, and we're forming something new coming from those two different disciplines. Now, the topic tonight at this Interfaces lecture has to do with circadian rhythms, and we have, excuse me, one of the speakers tonight is also a member of the faculty here at the Salk Institute. His name is Satchin Panda. He's right here in the front row. Satchin joined the Salk Institute, he tells me, 9 years ago. It seems like he's been here a long time. 9 years ago, he is an associate professor at the Institute, and he runs a laboratory in which he performs experiments to identify the molecular mechanisms for biological clocks. So you have a biological clock in you. It's what helps you do the different things you do over the course of a day in a sort of regulated manner. It's synchronized by light, and this is in part why light is such an important part of our environment, the environments that we dwell in, the environments that we work in, the environments that we learn in. And so what Satchin will tell you today is some of that basic biology that underlies this. And on the same program, we have Fred Marks. Fred is one of the founding members of ANFA. He's been with the organization for 10 years. And I've known Fred for probably 10 years. It's been great to work with him, but there are a few things I didn't know about him, about his background, which he's informed me. Actually, I did a Google search on him, and I found this really interesting, this picture of Fred, which is remarkable. He tells me it wasn't taken last week, but in any case, Fred got a degree in business from the University of Wisconsin. He was trained in architecture at Arizona State University, and he worked for some period of time with A.C. Martin in Los Angeles, and also with Earl Walls Associates in Los Angeles. And this is one of the things I didn't know about Fred, is that he, for a time, worked as an assistant to Morris Udall, who was a member of Congress, and a subcommittee on the environment, or environmental protection issues. And he did that while he was in Washington. He also, at some point, worked with an organization called Wright Ingram, which was, I'm not sure if I completely understand this, founded by Wright's granddaughter?
Yes. Founded
by Wright's granddaughter, and Fred was part of that organization for some time. And he is now consultant in science and technology for A.C. Martin in Los Angeles. And the way we're going to do this tonight is sort of point, counterpoint. We've done this in different formats in the past, where one person gives a lecture and the other person sort of attaches something on at the end, commentary on what the first person said. But we're going to do it, it's going to be more, as we believe, integrated this evening by having this back and forth between Satchin and Fred. And rather than me taking up the entire evening, I think I'm going to turn it over to them now. One thing I will say, however, before I give them the podium, is that if you are interested in these kinds of programs, if you're interested in ANFA and what we do and what we're about, please contact me. We have a website. It's in a sort of irregular state right now. We're working on that. We have a Facebook page. You can go to that. There is information on the Facebook page. And any of the board members, many of whom are here tonight, will be happy to talk to any of you about our mission and our interests and what we do, what we sponsor, and the kinds of programs we'll be having in the future. I will mention one last thing, which is we had our first major conference last September held here at the Salk Institute in this room. It was a huge success. Many people from all over the country came and joined us, architects and neuroscientists alike, and joined us for this. And it was a real eye-opening experience, and I think a big step forward for this organization. We're planning this again for next September, that is September 2014. And if you have interest in that program, we're putting it together almost as we speak, not quite, but almost as we speak. And it'll be announced when we get our webpage up and running again. It'll be announced on the webpage. But again, you can contact any of the board members and we'd be happy to give you information. And so with that, I'll turn it over to Satchin and Fred.
Well, thank you, Tom, and good evening to all of you. It is an absolute pleasure for me to be at the Salk Institute. I am humbled by the idea of being in this sacred temple of art and architecture. And it was some years ago, as an architectural student, that I first arrived here. And like Proust, who talks about his youthful days in France, I get a feeling every time I come back where all the memories of being 18 rush in front of me. And it's a pleasure I wish I had more often. So this being the exception tonight, thank you very much for giving me a reason to stand here. Before we start, I'd like to get a sense of who the audience is. So if by a show of hands you could say whether you're either in the sciences or in the art and architecture field, I'd appreciate it. So let's start with science first. We're getting nearly half, and then art and architecture. Anyone in basic design? Excellent. Well, again, the whole purpose is to have a mixture. We feel that the integration is extremely important, not only now, but most particularly for the future. So what you're going to hear tonight is an effort that Satchin and I have gone through for a number of weeks now, in seeing how we can meld these two separate disciplines and come up with something that will be of interest to you. So with that, why don't you come up, Satchin, and we'll start.
Great.
The format, as Tom hinted, is that we'll go back and forth. Satchin will begin the presentation. I will give my own interpretation through a certain section. Then Satchin will respond to my thoughts, and then the two of us will talk very briefly about the future, and hopefully after that it will encourage you to participate as well.
Thank you, Fred. Almost 6 months ago, Tom asked me to do this, and it was intimidating, but then I thought it would be fun, because being in Salk, in such a nice architectural masterpiece and starting clock, I thought this would be a nice opportunity to learn a little bit about architecture. And as Fred mentioned, for last few weeks, we must have gone through more than 20 hours of intense discussion about the topic. And today what I feel like, just like Fred said, he was feeling like an 18-year-old, and I would say, yes, I was also feeling almost like that. I feel like I'm giving my thesis defense or my progress report or something that happened in the last few months. And we put together quite a few thoughts, and then at the end what happened was I disappeared for 20 days to Nairobi, and some of the things that finally ended up in the slides were from the last few days in Nairobi. Okay, so Fred asked me to start from the very beginning, the presence of light, the heart of darkness. So I thought, well, I'll meld a little bit of my background in plant science, because I did my Ph.D. in plant science, and how I look at light on this planet and how things have evolved from there. So as all of us know, the rotation of our planet causes predictable change in day and night, and the intensity of light and its composition is perfect for supporting life. And if we take this ray of light and diffract it, then we'll find various spectrum, and what we say is visible spectrum ranges somewhere between, say, 350, 400 to 800. And if you look at this visible spectrum, this is the energy that we get from the sun, and life has to sustain on this. So the very basic form of life has to sense this light and extract energy from this. And those basic forms of life are plants, and plants, for some reason, they actually filter out two wavelengths of light on the far left and a little bit towards the right. They use that to photosynthesize and fix carbon, and that forms the basic material life form in our planet. But when this seedling grows up, it has to also sense where is the sun, where is light coming from. It has to get sense of direction, And to get that sense of direction, it uses two different type of light sensors, one in blue, one in red. And what is really interesting is some of these plant light sensors were discovered right in this building in Joan Corey's lab. But when this plant is growing on this shade, it has to come out of this shade. And that's a very tricky thing, because if you think about it, it's just different shades of gray that the plant is seeing. The plant has to find some pattern to figure out what is this shade and what is light. And it uses a different type of photoreceptor, light receptor, called phytochromes, and forget about that. It essentially measures the ratio of different wavelengths of light and finds pattern. So as we look at plants, essentially there are three major aspects of light detection. It has to detect brightness, it has to find direction and find pattern, and then come out and grow. And after plants, in the food pyramid, other animals came. And then the animals have to find plants. And if you look at this spectrum, I told you that the plants are absorbing in this area, and they leave this middle part empty. So that means they actually reflect that green. And for an animal to find a plant and eat, it has to have a green light sensor. Another thing that happens in the middle of the night is this animal who is roaming around at night has to sense starlight and moonlight to survive. And star and moonlight are also in that range. So essentially, all animals with an eye have to come up with a light sensor. There's a rod light sensor, it's not visible here, which senses light around 500 nanometer, right in the middle. But just like plants, they also have to find direction and pattern. So that's why almost all animals with an eye, they have one light sensor that senses to the right of rod and one to the left of rod. And then with trichromates, we can sense light in many different colors. But essentially with these, animals can sense all those three basic elements: brightness, direction, and pattern. There is not much discussion about how light affects mood for a very long time. But forms attract us, both artists and scientists, and this is a perfect example of how arts and science met almost 500, 600 years ago. As many of you know, this is a famous drawing by Leonardo, was impressed by Roman architect Vitruvius, who essentially showed how a perfect human body is composed of specific proportion, and those proportions form the basis of many architecture. And in the original drawing on the top is described how these proportions are. On the bottom part, it also describes about all these proportions related to this drawing. And what was really fascinating to me was all these proportions related to this square. Very little talked about this circle there. And I thought, well, I can kind of attempt to interpret it slightly differently. I think what he left out was the circle, and what I would say was for a perfect man to live, for a perfect person to live. His body also has to tune with the 24 hours day-night cycle. And over the last few years, now we have come to know that that's actually true. As we all get up in the morning and go to bed, we know that there is kind of a circadian clock or biological clock that helps us go to bed at a certain time and wake up at certain other time. But in addition to that, for example, if you woke up around 6 o'clock this morning, then your deepest sleep happened at 2 o'clock. Your body was coldest around 2 hours before you woke up. And then just like our body is anticipating waking up, our heart rate begins to build up. We have sharpest rise in blood pressure right before wake-up time. As we wake up and step into the light, that light suppresses melatonin, and then cortisol level begins to rise. We have highest alertness around 10 o'clock, so that's the best time to have some productive meeting, and then best muscle coordination, fastest reaction time, all of these things that relates to going to gym or hitting the sports ground happens there. And this happens in a very predictable fashion. And when our clock is desynchronized from our environment, and when we have various chronic diseases, we also succumb to many diseases. And what is interesting is there are also specific time of the day when more number of patients with specific problem get into the emergency room or seek healthcare. So you can see that the clock affects profoundly our physiology, metabolism, and behavior almost on a daily basis. But as we change season, as you might have noticed, and those of you who fly from East Coast to West Coast, or the daylight saving time, the clock has to adjust to this new day-night cycle. And for that, we cannot really rely on the rod and cone photoreceptor. I told you that rods can sense light in the middle of the night. And if those light sensors can reset our clock, then something terrible will happen. So this is one evening in Masai Mara base camp where we had our tent and there was a storm coming, and I thought I'll put a time-lapse image of the storm. We could clearly see the storm. We could clearly see some of the lightning. Maybe you cannot see because the light is too high here. But the point is, if my clock was sensitive and could be reset by that lightning or moonlight, the next day I would have woken up late. But it didn't happen because rod, cone are not used to reset my clock. And actually there are examples where this is an owl monkey which lives in South America, and this monkey is extremely sensitive to light. And primates are typically diurnal, and you can see it has a lot of activity during daytime. But as the moon goes through its normal phase, it actually tracks the moonlight because it's so sensitive to moonlight that it switches back and forth between diurnal and nocturnal behavior. So just imagine if you're stuck like owl monkey, then we'd be completely driven by moonlight or what time of the night we switch on light. And to give this, to explain this in more detail, here is activity pattern of a little mouse, because mice also have clock and they also wake up and go to bed at exactly opposite phase because mice are nocturnal. But irrespective of that, what you're looking at is each horizontal line is activity of a mouse held in constant darkness. So even under constant darkness, it wakes up almost 24 hours, actually 23 hours, 45 minutes later every day. And then one day if I go give a 15 minutes of light pulse, then next day the mouse will reset its clock. But another day if I go and give a 15 seconds of the same light pulse, then the mouse doesn't reset its clock. So that means there must be a light receptor that's less sensitive to light or is counting the number of minutes the mouse actually saw light. And to make a long story short, what we also found, and what was also known for almost 70-75 years, was you can take a mouse that doesn't have rod and cone cells, and this mouse cannot read the newspaper. This mouse can reset its clock, constrict its pupil in response to light, and can go to sleep when we switch off the light. And in the middle of the night, if you shine light, then the mouse will freeze, and it will have a really bad headache if it is exposed to excessive light. And we go through almost similar things. So if you have a normal person or somebody who is visually blind because lost rod and cone cells, this individual also will show the same response. So that means there must be a light sensor hidden somewhere that people had not found for 75 years. To make a long story short, almost 10 years ago, 12 years ago, we and two other groups, we found this light sensor, we call it Melanopsin. If you think about retina is a 14 megapixel camera, there are 14 million rod and cone cells or something around that. There are only 5,000 of these in each human retina. And these cells are directly connected, hardwired to our biological clock, the master biological clock that's present in the base of our brain, base of the hypothalamus. And many of you might have seen this kind of notation that two eyes send their input and these optic nerves crisscross at the base of the hypothalamus, and then this information is sent to the back of the brain where image is reconstructed. And Tom studies various aspects of this image formation and motion. What is interesting is right where the crisscross, that's where the master biological clock is. And those 5,000 neurons I said, they send their projection or they connect directly to these clock neurons. So now we can go back and revisit that plan and we can say, well, we also have another light sensor called Melanopsin, which senses at 488 nanometer. So that means that's cyan blue light. So now if we have that light sensor, then now we can explain many of these phenomena that we had seen in mice, and we're beginning to explain those phenomena in humans. So what it means is, if you have bright blue light, you can reset your clock much faster, either intentionally or unintentionally. And similarly, it can affect your sleep. So since we are diurnal animals, organisms, this blue light will wake us up and it will make us more alert. And if there is excessive of this blue light, then it can also exacerbate migraine pain. So we don't know how we evolved, means what kind of light environment we went through, and this is a snapshot from Nairobi National Museum, which has the largest collection of human fossils, almost 800 of them, and there are many in display. And I really like this display because it captures 1.2 million years of human history in various skulls and artifacts here, with a nice backdrop of where these people might have spent their time in this flat savanna. And we cannot go back and see how they spend their life, but what we can see is maybe check how Masai population, which is still living in the same traditional housing and lifestyle, how they live. So the place we went to was in the heart of Masai Mara game reserve, right outside Masai Mara. And these Masai villages are very small villages. There are only 10 to, actually this village had only 6 families living in one tiny hut like this. And at the center they keep all the cows. There are nearly 1,000 cows. So what you are seeing, that dark area is all the cow dung deposited there for a long time. And then these are the Masai houses. Oh, sorry, let's go back. And this is the typical Masai house built by the master architect, who is the wife of the Masai. And usually it takes 4 or 5 women. They get together, build this house in 4 to 6 weeks. This house measures around, say, 12 to 16 feet long and maybe 10 feet deep. And the height is around 6 to 7 feet. And the Masai couple and only the young children below the age of 5, they live in this house. And this tiny house actually has 4 or 5 rooms. But inside the house is extremely dark. So here are the inhabitants of that house. And what is interesting is these Masais will, in the morning the males will go out to the cow herd, and the females will stay back, and then after the kids turn 5 or 6, they also join the dad, and then they go out. So essentially, the entire family roams around within a very well-defined or very small area compared to what we do, maybe a couple of miles in radius. And the entire day they spend time outside, they barely sleep inside the house. The house is used only to sleep at night. And the house is built in such a way that there is no window, and I actually went inside, I have a light sensor always tied to my hand, and the light sensor read less than 20 lux of light inside a Masai house in the middle of the day at 12:30 in daytime. So next, let's go to another place. Masai actually, it takes almost 4 Masais to light a fire. And lighting a fire is very expensive for them, and they don't have much use of fire because they drink raw cow milk, and only once a week they mix cow milk with cow blood and eat that. But if you think of the biggest change that has happened in human civilization, I think the controlled use of fire was the biggest change. And it took us a little bit more time to actually reproducibly make fire, and that led to agriculture. And this is a farmhouse, or this is a small village in the east coast of India where I come from. And this is, you are looking at, sorry, just making it a mess. Let's see. This is house of a farmer, and this house was also built by the same person or his grandparent. And from this person was born there and spent his entire life there. And there is a house there, there is a pond there for fish, and then some vegetable garden, legume garden, and then this person spent some of time in the agricultural field, and then the area that the person travels most of his life was in a daily basis was 2 to 3 miles. And then now let's go to what his grandson is doing, and what you will see is things have changed in the last 40 to 50 years. And if we think about even our own life, we come to San Diego, and here is, we are sitting here. And let's go to the next slide. And what you're looking at is the places where this person spent or ate for over 2 weeks. And this is a good snapshot because you have timestamp, you have geolocation where this person is just eating. Because remember, in those 2 other slides, this Masai and then the Indian villager, they all came back home, they ate there. And this is a way we are actually tracking hundreds of individuals where they eat. And this is an interesting set of data. The scale here is almost 30 miles by 20 miles. And these are the areas where the person ate. And this is color coded, so those are the meals taken in the evening, and those are in the weekday, and then those are in the weekend. And if I just blow up one small person, then we can see that there is no pattern to this person. So we're essentially moving from one place to another, almost like that nomadic person few thousand years ago. And we see any person we zoom in, we find the same thing. So now let's compare how were these Masais, this Indian villager and his grandson maybe. So it's not up to scale, but still we can see the amount of the area that we traverse. Another thing is both of these individuals, they built their own house, they were their own architect, and they spent their entire life. In the evening, they came back to the house. They spent almost the entire night almost in low light condition or no light condition, and here the things changed. If you think of a typical person's life these days, and how if you have a family of 3, then these 3 individuals will wake up in the morning and go in multiple different directions. And over the next 15 to 20 years, you'll find all the structures these people will visit. So that means we have we've drawn ourselves from real nature, day-night cycle, to a different lifestyle where we go from one architectural piece to another architectural structure to another one, and we have no control over design of those structures as individual. But in this way, every structure becomes important in our life, because in every structure we want to see how the lighting intensity, direction, and pattern affect our behavior, physiology, metabolism, and mood. So that's what is kind of summarized here. And let's go back to a few more examples, because I just gave you a personalized view of what I feel. And you can see the same theme repeated again and again. This is a grass hut in African continent. Always the size of the hut is very tiny. They use it only for sleeping. Inside this hut, the light intensity is extremely low. And in North America, there are teepees, and the light intensity is not actually, it's a little bit better than here, but still, this structure is not used for anything other than sleeping. Now, if we fast forward, this is a typical house in United States, 1600. Again, the size is not that big. Means, if I have a house here now, then it will be a museum piece. Nobody will live there. And you see the same theme again and again. So what actually happened? What was the big change? What I think that big change happened in architecture, what helped us build bigger houses, the use of glass. Now we can build big house, have a big piece of glass. So in that way we can have our life inside the house, bring light inside, bring a little bit of what we see, sense nature inside, and we can now transition from this spending all of our time outside the structure to inside the structure. And maybe you can have some thought. So this is, in summary, this is what we go through. This is our living space. We claim as our living space, but we spend very little time only in the night time. Another thing that has changed is the night time used to be dark, but now we have complete control over lighting, and there are very few houses which have complete darkness throughout the night. And light being so cheap, now we can light our houses for a very long time. And this exemplifies in any city that we hop from one structure to another structure all the time. We are not static anymore. So I would like to have your view about what I think, and then we'll go from there. Thank you.
A connection between architecture and natural light goes back at least 4,000 years. And it is estimated that ancient cultures from all over the world built huge structures, hundreds if not thousands, stone circles, temples, secret inner rooms that aligned with the sun during its major annual stages, those stages being the equinox of March and September, and the solstice in June and December. Stonehenge may be the most famous and the oldest that still remains. The Great Pyramids in Egypt and the Ajanta caves in India came later, but they are still in existence. Acknowledging and appropriately responding to seasonal changes during the course of a year was a matter of survival, and architecture would be civilization's first time clocks.
With this one. That's fine. That's fine.
By the time of the Roman Emperor Hadrian, architecture became a well-established trade. And the Pantheon a Greek word for all gods, was a prime example. It has a requisite portico with Corinthian columns and a prominent rotunda under which lies the concrete dome, and with a central opening called an oculus, which was open to the sky. The light from the oculus, in this particular case, moves in a counterclockwise position. The Pantheon continues to be an important, influential piece of architecture and has influenced city halls, universities, and public libraries. An example of the 19th century would be the Bibliothèque Nationale in France. And 120 years later would be the library in Phoenix, Arizona, which was designed by Will Bruder. In Phoenix, every year on the 21st of June, over 1,000 people attend the marking of the summer solstice in what they call the Great Reading Room, which has a height of 32 feet. The building is designed for solar noon on that particular day, and the light from the sun shines through the skylight through a clear disk, and at a certain point emits a light on top of each of the columns, giving the impression that the columns are aflame. As the Roman Empire ended and Christianity became the prominent religion of the Western civilization, spiritual light became an integral part of the design of grand cathedrals as well as small sanctuaries. It provided a division between real and symbolic, between the holy and the material world. Light came from sources that we could not always see. The size and shape and composition of building penetrations have and continue to be influenced by many conditions: geography, climate, technology, politics, religion, cost, use, and imagination. Singly or in groups, they tell a story. The narrative begins on the outside of the building and follows through to the interior. The development of window glass began in the 13th century. It was not until the mid-19th century that duty charges on glass were withdrawn, leading to a great increase in demand as well as a commensurate reduction in cost. As load-bearing walls gave way to steel frame construction, glass became more and more dominant as an exterior material. As light enters a building's interior, it can be seen, felt, and redirected. At times, light may become almost a tactile substance. Light can formally accentuate lines, planes, seams, and diverge from the logic of built structure and introduce its own language of form and space. And it is the contrast between light and darkness that elicits our greatest response. Stephen Hull, American Institute of Architects Gold Medal recipient, put it this way: a building speaks through the silence of perception orchestrated by light. If we look to the top left image, it is a representation of an art exhibition that was developed by the artist Robert Irwin at the Whitney Museum of Art. And if you don't know, in the 1960s in Southern California, there was an art movement called Light and Space, basically because artists felt that there was tremendous potential in the expressiveness of light. To better appreciate how light may be transferred from the outside of of a structure to the inside, it's helpful to remember something about Euclidean geometry. Euclid's Elements, which was written approximately 300 BC, has been the cornerstone of how architects, intentionally or accidentally, use mathematical proportions to shape their buildings. The golden triangle was derived during this period, and Satchin has already made reference to it. If we move fast forward to 1917 and the founding of the Dutch movement de Stijl, we will see in Mondrian's painting a disciplinary placement of rectangular shapes and primary colors. As it happens, the horizontal and the vertical were seen as constituting the universal. The horizontal represented the course of the Earth around the sun. The vertical represented the spatial movement of rays from the center of the sun. The cube house in this case represents a similar discipline. As noted by E.H. Gombrich, the late British art historian, someone who Tom Albright has referred to in some of his ANFA lectures, we derive a visual comfort based on certain patterns. This universal appeal may be exactly the same at every scale or nearly the same at different scales. However, as Gombrich notes, novelty or excitement is just as important as our sense of pleasure is to familiarity. The Russian painter Kazimir Malevich founded what's called the Suprematist School in 1913. This art and architecture movement focused on basic geometric forms such as circles, squares, lines, and rectangles. But it also emphasized a non-Euclidean or non-right angle approach to pattern layout. By introducing irregularity, the resulting design was more closely representative of nature and, to a degree, what we now call fractal geometry. The architect Burke Engels started his architectural practice in Copenhagen, but he is not one to follow the conventions of modernism any more than an architect such as Frank Gehry. And I refer to Engels in this proposed residential building for Manhattan because Tom, again, had an opportunity to present with him in New York at the Rubin Museum just a year ago. This slanted pyramid-shaped structure faces southwest towards the Hudson River. And given Engels' innovation in multifamily housing, it is likely he'll be very sensitive to how light is received. And one final point. I do not want you to think that a building should be judged as if it was sculpture or a painting. They are not, in this case, architecture, a plastic phenomenon. The facade, no matter how beautiful, is only the container, and it is the content, the internal space, which is of utmost importance. Window shades have and continue to be the standard for controlling the quantity of light that enters a building's interior. Technology now enables shades to be embedded in a window and controlled by a light sensor. But more importantly, the exterior buildings are becoming more Baroque. That is to say, they are double-shelled and with the primary intent of reducing energy consumption. The examples being shown here, starting in the upper left, would be a commercial building in Barcelona, Spain. Below that, a youth center in Japan. And then lastly, a tech center in Australia. In terms of the tech center, it has 16,000 translucent, sandblasted, movable and fixed disks that move vertically and horizontally with the changing of the sun. To overcome the limitations of an exterior window, to bring full spectrum light to the center of a large floor plate, in this case, Ito came up with a novel idea of placing the mass from the roof level with multiple glass tubes for a library that in this case was designed for Sandei, Japan. This idea was further developed by Ralph Johnson of the firm Perkins & Will for a medical center in Chicago. In both cases, light has become more of a physical presence than a tool for something to see. In the absence of any natural light, one may attempt to imitate what is known as skylights. Frank Lloyd Wright did this for the Johnson Wax Company in 1935 using Pyrex tubes. Wright's interest in organic architecture led to what appears to be light streaming through a dense forest, which in this case are attenuated columns which appear to be mushroom-like. The firm Gwathmey Siegel out of New York used a different approach to bring imagined light to an Upper East Side residence in Manhattan. The idea that light could be created by connecting wires to a battery came in the early 19th century, but it wasn't until the beginning of the 20th century that we had the incandescent light bulb. Fluorescent lighting followed as a commercial product in the late 1930s. The upper left-hand image is that of the Union Carbide headquarters, designed by Skidmore, Owings, and Merrill. In 1959, it represented the state-of-the-art for corporate offices. Fluorescent lighting penetrated the ceiling, not only over the open secretarial section, but also over the corporate perimeter offices. It was all diffused down lighting. 60 years later, we have a different situation. There is up lighting to the ceiling, task down lighting at desktops, transparent walls to offices and conference rooms, and access to perimeter window light from most spaces. There is also, as you look to the right, the customization taking place for each worker, made possible in this case by Herman Miller Furniture. So where is light technology taking us? The section drawing of an observatory to the left and the fixture to the bottom right is from a recently completed project at California Institute of Technology in Pasadena, where testing is taking place to bring natural light from the roof to the inner spaces via fiber optics. The upper right-hand image shows a 50-watt equivalent LED bulb that can be used with wireless control system, synchronized to motion sensors and to home thermostats, to provide custom lighting environments with a choice of over 16 million colors. This final slide shows various interior lighting levels, metered for both natural and artificial lighting. The take-home message is that given our ability to accurately measure both lux and foot candles in a given space, the design community needs to be more responsive to how light, through all of its possibilities, may affect human health and well-being. Now, Edward Hopper rarely talked, or certainly wrote, about his paintings, but I think we can conclude at looking at this particular famous painting of his called Nighthawks, that the people who are sitting at the counter in this urban-like environment are sleep-deprived and melancholy. And with that, I'll hand it over to Satchin.
Yeah, I'll begin from the melancholy and sleep-deprived state. So, yeah, actually, what is interesting about all of the things that you told us was how building interior lighting has been the focus of architecture for a very long time. And with that, we're kind of coming to this yin and yang. One is from what we know from circadian rhythm or biology of clock, we need more light during daytime. We need less light or darkness at night time. But then if you continue dim light throughout night, since our light sensors, say Melanopsin, can actually integrate light over minutes or hours, can actually reset our clock and screw up many things. Another thing that we have learned from science, from working on how light intensity affects behavior, physiology and metabolism, mood, we know that low light intensity or exposure to very low light for a very long time does promote or predisposes us to depression and certain mood disorder, and increasing light intensity can, in many cases, can reverse it. So that brings this topic that how much light we should have where. And then the question of whether we should have monochromatic light, colorful lights, or how do we control our light environment. There is an image from Guggenheim Museum 2013 this year, James Turrell exhibit. Essentially what it does is he illuminates the entire room with one monochromatic light, and that attracts us, that we go there, we spend some time, we appreciate it, and then the question is, can we really adapt it to our lighting environment or our living space, or can we bring it to, you can say, if I take Fred's excitement about 16 million light color, can we actually have personalized lighting? Can I come to a room and slide the bar and say, well, I want to be in red light or yellow light or orange light? And what is it going to do to our mood? And these are really interesting questions, because now this is possible. Now we are not dependent on 3 colors of light that we get from Home Depot or any lighting store you go to. Another thing that has become also possible is these LED lights consume so little energy that you can essentially have a panel of USB panels on the top or side of your wall, and then can stick all these LED lights and can slide the mood switch on your iPhone or something and change the lighting. That's one scenario, but as soon as you step out of your house and go outside, although it says Times Square, but it's the same thing in many cities now. I was in Osaka, I was in Tokyo, and in Shibuya area, almost everywhere we face this kind of environment, and it's all night long. And then the question is, what kind of emotion, what kind of mood does this induce, and how does it affect our circadian clock? Or if somebody is working night shift in an assembly line, and we have controlled everything that we can think of for having a good clock, and then the person comes out and takes a 2 hours taxi ride or in the public transport through this lighting environment, then what happens to the clock? How do we control that? And I don't have any answer, but what I can think of from what I study is, can we actually now bring in something completely different to personalized health? Say, eyeglasses that will filter out blue light at certain time, and then you can change your shade during daytime. And will that happen? Will that help this person to go from an assembly line to home in the middle of the night in Tokyo or in Times Square. And I think the biggest experiment with light and dark has been done by Philip Johnson in his famous glass house and brick house. And this is something I did not know, and Fred introduced to me, and I was really excited about going back and asking, like I was asking Fred all kinds of questions, like, okay, so where did Philip Johnson spend all of his time? Did he choose this one or the other one? What is your natural tendency to do? Means this is a perfect example of living like a Masai, but with glass walls. So you can essentially experience nature. This would be dream house for many of us, and this won't be, because we are kind of excluded from the natural scene. And even if you come back and put all kinds of lighting, it may not be possible. So we went back and forth and we asked, look, what happened there? Who lived in this house? How long did they live? Did they actually come back again? And it seems this was used as guest house, and many of you might know, and the biologists who don't know. So this was used as guest house, and in the inside of the house, this is the bedroom or the bed space in that glass house. And since Philip Johnson was wealthy enough, could have a few acres of land around his house, he had the perfect privacy that in the night time, it'll be almost dark except for starlight and moonlight, and he could have a perfectly nice sleep there. But the brick house has few elements that, if we can think of going back to the same three elements of light: intensity, light direction, and pattern, we can maybe increase and modulate intensity, but there is no sense of direction. And that's very important, because if you think of any place where you have been, where there is no sense of direction, it's a uniformly lighted house, then I don't think we'll feel comfortable staying there. So it kind of signifies that direction does matter. And then pattern, the pattern is fixed. The person who is stuck there will look at the same pattern on the wall that's presented to him, which is a static pattern. And from biology, means it's kind of an interesting thing that I would always, maybe I'll go back and ask Tom, why changing pattern is important, why I cannot just look at the same Monet painting for 15 years stuck in a solitary confinement. So this kind of, it actually excited me and made me wonder these elements in architecture. And then that brings me to my ideal house, that if I had enough time, energy, and resource, then I would build something like this. From biology point of view, I can have enough light during daytime, can live with 1,000 lux or more, and at night time I can just switch, and this entire cover will just slide in, and I will be inside a Masai house with almost 5 to 10 lux, even after we switch off all the lights and cover all the LED indicators on my electronics. But we actually live in a mixed environment like this. We hop from one place to another like this, where we have some form of natural lighting with natural scene, and then in some places we are presented with high intensity of light, sufficient intensity of light, but with fixed scene. And then the question is, which one would we prefer, and how long can we stay in those places, and how it's going to affect us? The first thing is, if I'm stuck in this area, then I would lose the sense of time, because it will be constantly lighted and I have no natural scene. And I lose the sense of direction too. So it's interesting that instantly, for a short time, it excites me for the uniqueness of the pattern. For long term, it may not help me. And this has been used again and again in architecture in various kind of settings, where we want to be excited for a few seconds, for a few minutes. We can spend a couple of hours there. It may not be the whole day or a year. And that's how I look at it. Then, if we think of, as I told you, we go through different buildings, different rooms even in the same building, and then the question is, how do we light various areas of our... This is a conference room, as you can see. There is sufficient light coming from the top, And here is a small meeting place, again with meeting area for a couple of people. And what is interesting is in both places there is sufficient light, but the design is very different. And this offers both privacy and lighting. And when I think of our working day, and if I have to go through my work life like this, then I would be very happy, because throughout the day I'm exposed to sufficient light. And at the same time, it gives me change of scenery, change of little bit change in mood and this stuff. These are some of the images that Fred showed me and then asked me, what do you think of this? And I thought this is really exciting, because on one side, on both sides, I think if I go with my light meter, the light meter will give me very similar reading. But what I see here is an enclosed space where there is no sense of direction. And what I feel, and maybe some of you might correct me, and I don't know the biology behind it, when we lose the sense of direction for a while, then we get disillusioned. And that can be exploited in a very well in this kind of setting in a casino. And here is another space where actually the lighting is same, but there is a sense of direction because there is a glass wall at the end, and it gives both a sense of direction and also changing scene on this side. And here it's exploited in a very different way, because light improves alertness, and it also improves your executive function, it improves decision making, and maybe knowingly or unknowingly, Apple Store decided to have a design like that. That's what was my interpretation when Fred showed me. But then we come to this slide where actually it reminds me of another slide that Fred showed, that inside a religious space, what is commonly exploited in many architectural design is you make the entire big room dark and put light at the end of it, and at one end, and it gives us the sense of direction. And that's exploited again and again in religious places, and also right now here, all of you are sitting, and only one end of the hall is lighted, and we get attracted and we look at it. But it doesn't serve always the same purpose. For example, this is a secondary education classroom, a middle school room. And what I think here is lacking is there are a few things. One is the light may not be sufficient. Means if you have a board there and you switch off the light and you're sitting there all day, just think about if we had this meeting from morning to evening and you'll be sitting there and I can go back to my light meter, it will be less than 100 lux for the entire day. And if our kids go and sit in this darkened classroom with less than 100 lux, they will develop some kind of psychological problem. Means that will predispose them to depression and other stuff. Whereas here, there is a nursery in Japan, and what I really liked from some of the ancient Japanese architecture is their use of thick paper to diffuse light and bring sufficient light inside the living space. And I think that has gone from one generation to another, and even nowadays we see the same theme here, that there is enough diffuse light inside, and if I take my light meter, then it will be around more than 300 to 400 lux, which is pretty good amount of light for these little kids. So now the question is, how do we go to the future? Because I think what will happen is there will be less space available for us to live. The size of our houses will again shrink back like the Masai House, or maybe a little bit bigger than that. And we'll be hopping from one place to another. But at night time, we will come back to the same place. And at daytime, there may not be enough areas outside there where we can enjoy the natural scene. So how can we deal with that? And I think it's up to you, Fred. What do you think?
Partly up to me. In 2003, there was a very interesting exhibition that took place at the Tate Modern in London in what they call the Turbine Hall, which had recently been renovated. The installation artist Oliver Ullison did something called the Weather Project. And it caught my attention because not only did it become the most popular exhibition of his work, but it was still is, one of the most popular exhibitions that the Tate has ever had. It was during the winter. London is cold and gray, and there was something inviting about coming into a space where this enormous sun, which was powered by 18,000 watt bank of yellow streetlight bulbs, would take place. But we need to keep in mind this is all faux. It's not the real sun. Yet people continued to come into this space and almost in a hallucinogenic way respond to how they might if they were outside at the beach enjoying the sun. The way that the space was crafted is that the ceiling was mirrored so that one could be a part of the art exhibition. They could sit on the floor, see themselves, and also see the sun reflected. But it is about immersive design, and it's about storytelling, and it made me think, are we moving more in this direction as technology is changing? With that thought, I began to use the term convergence between architecture and the flat image. All of you now work with computers. We have television sets now being produced in a 4K and an 8K high definition pattern. The ability to truly understand, certainly from a distance, whether it's real or not real is getting harder. And as the New Yorker cover portrays, this is a case where one might be anywhere in the world. Let's think that we are in Copenhagen during the winter. You don't have sun for many hours during the day, and yet one might be able to achieve indoors a situation in which they pose for themselves a backdrop in which they think they are in summertime in a garden with a certain amount of lux, and emotionally and spiritually are affected by that. In the case of Bill Gates, he had a private home built for himself in Seattle a number of years ago by the design firm Bolin Zawinski Jackson. And throughout the home, he has full wall screens which he can modify depending upon the guests who come in, whether it's a change in artwork or any other subject. So taking this to the last stage, what I'm posing tonight is that we're going to be involved in architecture where that image becomes part of the wall facade itself, that you interact with what you see, and that which you see interacts with you. And architecture will be both three-dimensional and two-dimensional, but only two-dimensional to the extent that you don't remember that, in fact, it is in 3 dimensions. So with that, I'm going to allow Satchin to make one more strong point along these lines.
Yeah, so this is, I think, the best virtual reality we have been experiencing are rectangular pieces of glowing objects like TV, iPad, iPhone, and everything. And if we can dim the light a little bit more, then let's try something that's actually getting into what I feel is when something is in Hollywood movies, then maybe a few years later that will show up in our house. And here is something from the movie some of you might have seen, Cloud Atlas, where these two individuals go inside a room which doesn't look like a house, and then how they change. Almost every panel is a LCD panel, and you can see how Let's see how they interact inside that house. So the floor changed, and we changed the wall. This is watching the TV news. So I think that's what is in our future, that we'll have virtual reality in many places, and then the question is, how do we control our exposure to light, and how do we come up with personalized lighting, part of which will be managed by the architecture itself, and part of that will be controlled by us. And with that, I'll stop here.